I need to take off this chef hoodie and change it to my chef t-shirt because that thing's warm. All right, so 5 things you didn't know about Chef. Before I start talking about Chef, I want to talk about myself because this really is all about me. I'm a technical community manager at OpsCode. Really what that means is I do a lot of project management related to things in our community. I am a systems administrator by background, so I'm an ops guy. I like looking at sparkly graphs of all those cool code metrics you just added to your application, and also getting paged in the middle of the night when that code falls over for some reason. Not that your code falls over. That never happens to anybody's code here or anybody else's. I'm just speaking theoretically. I work on our open source Chef cookbooks. So if you've used Chef, then you may have come across cookbooks. And if you have used the ones from OpsCode, chances are my code's running in your production systems. Sorry. Or you're welcome, depending on how well that's worked out for you. I like to drink coffee and beer. I haven't had any beer yet, so that means I've only drank coffee so far, so I'm going to talk really fast. And I apologize for that in advance, but we'll see how this works out. So who are you? Who's by trade a systems administrator? You've mainly done operations work. A couple people, maybe? Who's touched systems and logged in and done SSH? Okay, cool. All right, so you recognize that prompt. Did you ever check the RSA fingerprint of your SSH keys? No? I do, because I'm weird like that. Who's primarily a developer? That should be like everybody then, right? Who's a business people? I have manager in my title. That kind of makes me a business people, right? If you're a consultant, you're business people. You got to, your one-man show. You got to, do the accounting and the coding and everything else, right? Who's a DevOps? A few people are DevOps. Actually, if you listen to Adam Jacobs' talk on the topic, DevOps is a movement, and you can not be a DevOps any more than you could be a hip-hop, because hip-hop is a cultural movement. But that's neither here nor there. Who's using Chef now? A few people. Who wishes they were using Chef? And who wanted to hear me talk about Chef versus Puppet? Well, sorry. So I have 72 slides, actually 74. I added a couple more after I added this one. And I did a check. I have 97 build steps. So there's a lot of stuff in here. I actually go through some of these slides fairly quickly, so let's get started. So first of all, what is Chef? It's an automation platform for developers and systems engineers to build and manage infrastructure as code. What? It's a technical domain revolving around building and managing infrastructure programmatically. That's infrastructure as code. What? Who doesn't like the WAT duck? Yeah, nobody doesn't like the WAT duck. Everybody loves WAT duck. So Chef is a framework. It's a framework built to bring you the benefits of configuration management across your entire infrastructure. So we're talking fully automated infrastructure, soup to nuts, the whole deal. Chef has some design principles that are very important to understand. The first one is that it's reasonable. You can look at the stuff that's in your Chef code and understand what's going on. You can reason about it. It's got declarative syntax. It's pretty easily strung together. You can make sense of things. And so when you're trying to fix systems at 3 a.m., you can reason about it and figure out what's going on easier. Chef is idempotent and convergent. Idempotent in this regard is not the pure mathematical sense of the word, but it's the idea that when Chef is configuring a system, it only takes action if it needs to. So if a package is already installed, Chef doesn't try and reinstall it. But Chef is convergent, so if the package is already installed, but you told it to upgrade to a newer version, Chef will take care of that for you. Chef is also designed to be flexible. In the world of managing systems and infrastructures, every infrastructure is a unique and special snowflake. Even though they're all pretty much the same. You've got a backend database, and you got a queue, and you got a cache, and you got a web app, and you got an iPhone app, and you got anyway, you've got all this stuff, but there's all the little differences that make companies unique and their infrastructures unique. They bring their own unique set of problems and challenges. So you need a tool like Chef that is flexible in helping you overcome those challenges. And so Chef is flexible in that it gives you a library and a set of primitives, and some of the things I'm going to talk about are using those primitives to build up and make the automation platform that you need. And has anybody ever been involved in Perl or the Perl community and recognize this acronym? So there is more than one way to do it. The idea that there isn't just a single way to write a particular bit of code. There's 16 different ways to write a bit of code, and Chef takes this to infrastructure in that every infrastructure is different. So the best practice for managing infrastructure with Chef in a bank is going to be different than in a media company, and is going to be different than a web startup. So Chef takes these together and builds and is a framework that embraces these principles. And it enables infrastructure as code. So you write Chef resources into recipes. So this is just a recipe for installing and managing HA proxy. Uses this declarative syntax. You collect all your recipes together into cookbooks, and you compose those together with roles. And you store all this as source code in a Git repository, or Subversion, or Bazaar, or whatever it is that you use. And you can manage it from source code. So now we all know what Chef does, and we're all experts in the subject. Let's talk about some of the things on my agenda. I'm not going to read all these slides because I have several slides about each one of these. I've got five topics here, and given the amount of time, I may or may not have the bonus round. So if we get to it, there will be a bonus round as well. The first topic is in-place file editing for the greater good. And I'll explain what that means here in a moment. I just need to update this one line in this config file. Anybody recognize what config file is in the background there? Call it out if you know it. That's right. This is just default IPv4 and IPv6 settings. I couldn't get an example that had a good mix of other tuning. But anyway, maybe you wanted to modify that one right up there, TCP SYNAC retries. Right? So that's the only one you actually care about in all of the sysctl. I just need to update that one line. Or maybe you're a PHP developer, or you have to maintain a legacy PHP app, and you need to update the INI file to point to one directive, right? There's a danger in this. And some would call it an anti-pattern. I prefer to call them alternate implementations. The danger here is that, well, it makes it hard to reason about managing this file. If I've got sysctl that has all these various configuration settings, and my app needs to change just this one line, but what if somebody else's app that's going to run on the system needs to change another line? Well, now we've got two potential places where we're making edits to the same file. So there's a danger in that. Generally, what we recommend is that you manage the whole file. Chef has a number of resources for managing files, like templates, cookbook files, remote files, etc., that manage the full content of the file. So you can render out a template, like we saw earlier with the ERB Puppet example. There's similar functionality in Chef. So we recommend doing it that way. But sometimes you really just have to modify a single line in a single file. A common example of this is modifying Etsy hosts. So Chef has a Ruby block resource, and we can just stick some Ruby code in there and be awesome. The heart of it is this class that's built into Chef that's not widely documented because we consider this to be an implementation we'd prefer not to use. But we're going to use Chef util file edit. We're going to pass in the argument of the path to the file that we're going to manage. And then we're going to send the appropriate file edit method to that object. And it's going to take the arguments. The first argument is, in this particular method, is a regular expression. And then the second argument is the new string that we're going to put into the file. So when we process this, when Chef processes this code, it's going to look at Etsy hosts, and it's going to replace the localhost entry with the new fully qualified domain name and new host name that we've set for localhost. And then finally, it writes the file to disk. So this is a Chef resource. We haven't done anything to ensure that this is going to be idempotent. So every time Chef runs, it's going to do this. Hopefully our regular expression is correct, and we didn't introduce two new problems by using a regular expression. And hopefully that line of text is going to end up being correct. We could put a guard in there that says, don't do this if it already exists. Search file replace line has a little bit of that in there. We're using the regular expression. Chef util file edit has several other methods. They're blurry and hard to read, and if you're in the back in the cave where the lights aren't on, I don't know if you can see all the text on here. The main ones that we use, search file replace line, which is the one we just saw, or we give it a regular expression and a new line. That's pretty straightforward. Then there's also search file and replace, and that's going to replace all occurrences of the regular expression with the text to replace. The other ones aren't used as commonly, but then there's also insert line if no match. So this is appending a line at the end of the file if we didn't have that in there. So if we wanted to make sure that a config setting was in a file, then we would use that method. And then, of course, there's the write file method, because it wouldn't do you any good to do all this text replacement without actually writing the file content out. Sean O'Mara, one of OpsCode's consultants, wrote a cookbook called Line that gives you a resource and provider for managing single lines. We hadn't done this up until he wrote this, because, like I said, we see this as kind of an anti-pattern. But as we see Chef used and adopted by more and more organizations, we're seeing different implementations and things that they want to, pain points that they want to use Chef to replace. So this is one of those pain points that they're encountering. They've got that monolithic, huge config file for some application that all they need to do is just update this one line for the new way they're deploying or whatever it is. And if you go to ckbk.it/line, that'll take you to the Chef community site where you can download that cookbook and check it out. On to the next topic. Number 2, using Chef's built-in version matching. When we're working with infrastructure and managing software, there's a bunch of places where we want to match versions. Platforms all have different versions, which can be fun, or it can be fun. Cookbooks have different versions. So when you're using Chef, cookbooks are bundles of code. And when you have bundles of code, you usually want to have them packaged in some way and give them a version so you know which particular one you're working with, which iteration, right? And then, of course, there's software and other packages that you may be managing that has versions. This particular library came about when we added version constraint support for Chef environments in Chef version 0.10 in order to match cookbook versions. And so that's where it came from, but it has more uses than just internally inside of Chef. The version constraint class can match versions that are in dotted notation up to 3 places, so X, Y, Z. You can do 5.6, 1.0, 1.8.0. It doesn't support alphabetic versions like 1.0.0.dev or -rc.1 or anything like that, but you can use it for things like OS platforms, cookbook versions, and most software does follow the numeric-only 3-dotted notation. Most common example that I found when I was implementing this was for version matching. I wanted to see if the version of Ubuntu I'm on is greater than 10.04, because greater than or equal to 10.04, because I know that that particular version introduced new features in the OS or new different patterns within the software that I'm managing. Or I can check for versions that are equal to 6.3 because maybe I'm using CentOS 6.3 and there was a change in 6.4 to some particular application. I want to make sure that, that my version is correct before I try and modify that application. So the version constraint, Chef version constraint class does first class comparison operators, allowing these version strings. And it's not lossy, unlike potentially 2i or 2f. I mean, in the earlier slide, I did a .2f on it, changing it to a floating point number. But if I took a 6.0.3, I dropped that 3, and I could potentially not get the exact version match that I wanted. The documentation for this is on the documentation site, so there's all kinds of additional information about this there. So how to use it? Well, you require the library. Then you initialize an object, passing in the constraint as the first argument. and then you send the include question mark predicate method with the version you want to match. The constraint operators, this should look familiar to people who use pretty much any version constraint matching system, such as Ruby gems. We've got equal, greater than or equal to, less than or equal to. I think in some cases this might be swapped if you're using Ruby gems. I believe that's swapped around. We did it this way because it lined up with the greater than equal to. And then there's approximately greater than the pessimistic operator for matching, if you don't want to get patch releases or if you don't want to get feature releases, assuming that things are following semantic versioning. So chef version constraint, here's some code. We require chef version constraint. And then I've got 3 different comparisons. I'm on an OS X system, and I'm going to check if my platform is greater than or equal to 10.7 or Lion. On 10.6 on my Snow Leopard system, it's false. If I'm on a Lion system that's at the 0.3 release, then it's true. And if it's on Mountain Lion, because mountain lions are cougars, then that's also true. We can also use any node attribute that might have that kind of string, a version string. So node's platform version has a string. So if I'm on a CentOS 5.8 system, node platform version is going to be 5.8, and it doesn't meet the pessimistic greater than 6.0, but 6.3 does. So fairly straightforward, just a couple lines of code to get some pretty neat version comparison. If we're on Debian 6.0.3 and we .2f that, we get 6.0 is the result, right? So if it just drops the .3 and then that returns true. And that may be what we want. Or if we're going to do a comparison if it's less than or greater than, well, 6.0 is less than 6.0.3, but when we drop the 0.3, it isn't because it's 6.0, it's equal to, so that actually returns false. Similarly, when we check to see if it's greater than, and 6.0.3 is greater than 6.0, but when we drop that, it isn't, it's equal to, right? So chef version constraint to the rescue. Check to see if it's greater than 6.0. Does it include that? It sure does. And Bob's your uncle. That's all I have to say about chef version constraint. It's pretty straightforward. It's a few more lines of code than .2_f, but it's a little more easy to reason about. This is my cue to take a drink of water. Who likes REPLs? REPLs are awesome. Who's used IRB? You've used a REPL, right? Who hasn't used IRB? A couple of people. You should. It's neat. So REPLs are handy, especially when you're debugging your code and trying to understand how things are going about. So Chef has a REPL. And in Chef 11, that REPL is called Chef Shell. In Chef 10 and earlier, it's called Chef. We can kind of see why there was a name change here. Also known as the unfortunately named Chef with an S. It's great when you're typing it. It fits that 4-letter Unix command model, but it doesn't fit the phonetic pronunciation in English model very well. Chef Shell is built on IRB, so it's really just running IRB with some Chef stuff loaded in. And it has 3 modes, or what we call contexts. There's the main mode, the attributes, and recipe modes. So first of all is the main mode, or the main context. This is generally used if you want to access node attributes. You can poke around and see what attributes are available. You can play with the Chef node object. That's kind of neat. But then there's a bunch of methods that are available in this mode that allow you to interact with the Chef server. So it's IRB with all the Chef stuff loaded up. So let's fire up Chef Shell. This is my live demo. I've learned my lesson. Don't run live demos unless you're Jim Wyrick, because he does great live demos. So I fired up Chef Shell. it prints out some information. I'm using chef 11.2 and so on. And then down here at the bottom, I have a chef prompt, this indicating that I'm in the main context. From here, I can get help. I can do help. Oh, my witty and wonderful thing didn't get typed. You can also type HALP, H-A-L-P, and it will return the same thing because internet memes are funny. So there's a lot of commands, and they all have descriptions. There's things like being able to interact with the chef server. There's a few others, and this includes the commands to switch you into the other modes. So in the main context, many of these commands that are available are for working with the API, like hitting the nodes endpoint to be able to query all of your nodes, or the client's endpoint, or working with data bags and that sort of thing. But this only works if you're configured to use a chef server, so let's restart chef shell with a chef client configuration. So if you use chef shell -z, or -z if you're in the UK, then it will automatically load up etsy chef client.rb. You can pass in a configuration file to use as well with the -c option. And then I can enter chef :config and then give it the chef server URL. This is a hash-like object that has all your configuration, and we can see that I'm connected to the ops code hosted chef server, and then I can get information about the node like its run list, and then given that I have this run list and it knows about this node object, I can talk to the chef server and find out which cookbooks I need to get. I can download those cookbooks automatically within the chef shell and be able to see how I can debug if there's a problem going on or if I want to find out how something works. The attributes mode is in the context of a cookbook attributes file. How many people have worked with Chef and are familiar with attributes files? A few people. This is where you set up cookbook-specific information, like which port Apache should listen on, or what username should deploy an application. You can enter the attributes mode, and it's just like working in the same context as a cookbook attributes file. So this is useful if you want to paste content from your attributes file into attributes mode, and then it will load up in the same way that Chef would if it were doing an actual run. This follows all the same order of operations loading of attributes that Chef follows, which is documented on the documentation site. So if we start up, we've already started up our Chef shell, we go into attributes mode, and then I use the default method. Default is a node method on the Chef node object, and I'm going to give it a key name, which is going to be a new attribute called Chef with an S, because I thought that would be fun to use the old name. And then it returns that we got fun there. And then in older versions of Chef than Chef 11, you couldn't modify the node attribute directly. You'd have to use one of the precedence methods like default in order to set the attribute. So when I try and use node chef equals awesometown, I get an exception that says that it's immutable and you have to do it like this. So instead, I do it like it says, node.default chef awesometown, and now that node's attribute is equal to awesometown. There's no semantic difference between node.default and default in an attributes file or an attributes mode. It's all done under the context of a chef node object. Well, why don't you just make it require chef dot and then the default in the attributes files? Well, it's like there's an evolution of a product, and we've got people using a particular way, so we didn't want to change it and then make them rewrite all of their attributes files across all of their cookbooks. They just have to change the ones that are trying to do assignment like this, which should be a smaller number. Chef Shell's recipe mode is probably the most fun and interesting thing because it's just like you're using Chef when you're writing recipes. So this is the context of a Chef recipe. It means that all the resources and recipe DSL methods that are in Chef are available. And if you're using a Chef server or if you've configured the Chef shell appropriately, you can get all of the cookbooks that you have. So if you've written your own resources and providers, then you can use those in the Chef shell as well. This makes it very highly useful for debugging, just like any good REPL would. And you can run it in client mode to interact with the chef server and see if the search in your recipe is actually going to behave like you think it is. Or you can find out why it isn't, perhaps. So we'll start up our chef shell as root in client mode, and then we'll go into recipe mode, so recipe underscore mode, and then I'm going to write a couple of resources. I'm going to have package get, package Emacs. These are going to return back the resource objects for that. I've snipped out all the additional stuff because it would make the slide look really silly with a bunch of light gray text. So after I've added these two resources in this recipe, then if I run the resources method, this is in the recipe DSL, and resources returns an array of all the resources that Chef knows about. And then if I were to run Chef on the system, since I did this as root, it would install Git and it would install Emacs. And then I would be happy because I like Git and Emacs. If I wanted to use search, so one of the Chef server's best features is the search API. If I wanted to use search, I could search for all the nodes that have the role workstation, because I manage all of my workstations with Chef. So I'll get back an array of node objects. Doppelbach, Champagne, and Merlot are my workstation systems. If I wanted to load up a databag item using the databag API, I can load the user's databag in my user, and then I get a databag item back, Timberman with my groups, and a comment, and there's some other stuff in there that I truncated also because slide space. So the Chef shell is a wonderful tool that you can use you can just run that and then paste some code in and see how it goes. And then it also has an extension library. So I can fire up pry. So some people use IRB. How many people are using pry? If you're using IRB and you're not using pry, you should use pry because pry is way, way cooler than IRB. So you fire up pry, require chef, and chef shell ext. So this is going to make available the chef shell's extension library. And then I do the shell extensions extend context object self, and then that makes available all of those methods. When I typed help earlier, that list of commands, those are all now available. So I can use this in knife plugins, I could use this in library, I could use this in my application in order to talk to the Chef server, get configuration back, etc. Here's a picture of some funny cats. Next topic, taking the resource collection for a stroll. What is the resource collection? Well, I'm glad you asked. The resource collection is an internal state object that Chef creates when you write Chef recipes, and it loads those recipes. It is looking for resources in those recipes, and it uses the magic of method missing. Yay, method missing! And each time it encounters a thing that it doesn't know about, it uses method missing. It says, oh, is this a resource? Oh, it is. I'm going to use the string argument and the block argument to create the resource, and it adds that resource to the resource collection. Then, after Chef has processed all of the recipes for the node, it walks through the resource collection, iterating over each of the resources, and then does whatever it needs to do to configure them. So let's consider this recipe. I've got a package Apache 2. I've got a template for the Apache 2 config file that's going to have a few parameters or arguments to it. Then I've got a service Apache 2 that also has some parameters and arguments. And this resource has an action declared, enable, and start. The other two don't. If you don't declare an action for a resource in Chef, then the default action is used. In the case of packages and templates, packages would be installed and templates would be created. Chef takes the most positive action by default, but you can always tell it which action you'd like to use. So each action differs by resource. You can find out by firing up the Chef shell and typing these in and seeing the results on your display. So if I take that recipe and I paste it into the Chef shell and then I run resources, then I get this list of resources, the three that I had. So the resources returns an array, but each one of these is included in the resource collection. The resource collection is a resource collection object, which is a hash-like object. And each of the resources has a type and a name. So we've got a package type, a template type, a service type. We've got an Apache 2 name for the package, etc Apache 2, apache2.conf for the name of the template, and a service Apache 2. So we've got 3 resources, right? When Chef runs, it creates a run context. I'll talk about that more shortly. But this is tracking the context of the Chef run. And the resource collection is part of the run context because it's only during this particular run that we have this resource collection. If you change your recipes, then you rerun Chef, you're probably going to have different resources. So it's different every time. So you access the resource collection directly by using run context.resource collection. So firing up Chef shell. Now you see why the Chef shell was before this one, right? Run context.resource collection gives me a resource collection object with an object ID. There's a bunch of data in there about all the things in the resource collection. The main thing that we're looking at here is the resources by name. So we've got a package Apache 2, a template, etc Apache 2, apache2.conf, and a service Apache 2. Note that each one of those has a numeric index. When Chef is finished processing all of the recipes for the resources, it iterates over that index in the order that they were added to the resource collection to configure them in that order. Because you can't enable and start the Apache 2 service until the Apache 2 package is installed, right? And this is the thing that when you use the resources method, then it looks up and retrieves those the keys from that particular hash. So if we use this in a recipe, I'm going to be sneaky and use this in a Chef shell recipe mode. I can do run context.resourcecollection.each. It's enumerable, so I can iterate over each of those and say that R is a resource name. So package Apache 2 is a package, is a template, and so on. I can do other things with these resources. So there's a bunch of other state that's tracked inside the resources. I can find out all of the package resources that are in the resource collection, and I can make a list of that and create an email and say that these are all the packages that Chef thinks it should manage. I can find out all the resources that at the end of the run have been updated and in some way were changed, whether a file mode was changed or a package was installed or a service was started or restarted, etc. Those all get set to be updated in their internal object, and I can grab that information. I can also go through and modify different things based on that. So there's a lot of flexibility in playing with the resource collection. Next topic is the anatomy of loading and executing a single recipe. Cupcakes are delicious. Chef Apply is a new program that's included in Chef 11. It's available if you install the Chef packages from opscode. We have a /usr/bin/Chef Apply. If you're on Windows, it's in your default path, so Windows users rejoice. We set that up for you. This all started from a gist written by Dan DeLeo. Dan DeLeo is an opscode software engineer and developer. He has written a lot of the client-side code in Chef, and he wrote this gist to illustrate that you can run a Chef recipe without creating all the ceremony of making a cookbook. So then from there, Brian Barry, co-host of the Food Fight Show and a member of the community, created a ticket to add Chef Apply to Chef, and he added some additional features, which I'll cover at the end of this section. So first, we're going to require the libraries we need. We need the Chef client library and the providers and resources. Then we're going to set up the run context. So this is all in that gist, essentially. First thing we're going to do is we're going to make sure that Chef is in solo mode. So Chef works with a Chef server, or it can work in a standalone or solo mode of operation. So we're going to make sure that it's set to true so we don't try and connect to a Chef server or get some weird timeout or something like that. The next thing we do is we create an instance of the Chef client class. So that we're going to create that client, and the Chef client class is the thing that keeps track of, is the main object in the Chef run that we're going to keep track of all this stuff about this particular node that we're managing. So we're going to build the node. We give Chef node build and apply node string that just tells it what the node's name is. It doesn't matter for all intents and purposes, because we're not talking to a chef server that needs to know what the node name is. We're just parsing a recipe. Then we're going to tell the client to run OHI. OHI is a data discovery tool that we use with Chef that discovers attributes about the node, like its IP address, its platform and the platform version, and so on. And then we build the node object applying the attributes to the node. Then we set up the run context. So we had to do all this ceremony in order to do this ceremony. So the run context takes a node object, a cookbook collection, and the events for the client. The node object we just talked about, it's going to have all these attributes from OHI. The cookbook collection is just an empty hash because we're not loading any cookbooks. We're just going to parse this single recipe. And then events is this all the things that have happened in a run, such as a resource being updated. So this is part of a feature that came along with our output formatters and yrun mode, which I'm not going to talk about, but I'm going to drop that there. But client events is required for run context in Chef 11. So here we're going to load the recipe. So Chef Recipe is a class that takes the cookbook and the recipe that we want to load, and then a run context. If we're using an actual Chef cookbook with Chef Solo or Chef Client, that cookbook collection wouldn't be an empty hash. It would have a bunch of cookbooks and recipes that they would be passed into Chef Recipe in order to be loaded. And then once we've created the recipe, we can do from file and load that recipe. Then we're going to create an instance of the runner. And the Chef runner is the thing that actually runs Chef. It's the thing that takes that resource collection and configures all of those resources on the node. So if I were to take that resource example from earlier and paste that into a file, and then run chef apply against that file, it would install the Apache 2 package. It would try and configure the template. That would fail because there isn't a cookbook for that template's source file to come from, but you could modify that in some way. You can tell a source that's local on the file system. You could create that and manage it, and then it would manage the service. So that's an easy way to prototype recipes and to do quick one-off kinds of things. You can also use chef apply with standard in. So in my shell, I can do while true, and I can run netcat on port 8787, and I can, as root, run chef apply-s. Then I can telnet into that system and give it a recipe, resources, whatever I want, and then send the telnet escape sequences, and then that loop would apply it, and then it would start over, and you could do it again. Of course, never actually never type this code into any terminal ever. Unless you're doing it like in a VM, but even then, don't do it. And there's a lot more to Chef than what I've talked about. There's more information about Chef. We just launched learnchef.com. That's a site that has a bunch of quick start guides and walkthroughs and that sort of thing. We're building up use cases and that stuff for LearnChef. We have the opscode installer is a full stack installation package of Chef. We have the documentation site. The mailing list is the main place where people have discussion. There's also IRC. We have the community site where you can download pre-made cookbooks. I'm Joshua at opscode.com, and I'm Jay Timberman on pretty much anything I can get that user ID. Looks like I got a couple of minutes before I wrap up. ChefConf is coming up. It's in April. You get a 10% discount, Big Ruby. So if you want to attend ChefConf and hang out with a bunch of other Chef users, we've got workshops and presentations galore, and it's going to be awesome. So you can go to chefconf.opscode.com. Yeah, chefconf.opscode.com. Use Big Ruby as your 10% discount. Might have time for a bonus round. I'm going to go through this. This is some frequently asked questions. So how do you test cookbooks? Well, first you attend Nathan's talk tomorrow. He's going to talk about testing. Chef 1014 and above has a Y-run mode. That's like no-op or dry run. We have a tool called Test Kitchen that'll help. There's a tool in the community called Chef Spec. There's another one called Cucumber Chef. Nathan Harvey's going to talk about some of this stuff and more, so don't miss that. Next FAQ, why is Chef Server so hard to install? Is that because you want people to use Hosted Chef and Private Chef? Well, yes, we do want people to use Hosted Chef and Private Chef, but it's not because that's not why we make the Chef Server hard to install. For one thing, it isn't anymore. We have a full stack package that makes it actually very easy to install. You retrieve the package and you install it, and boom, it's up and running. The idea of a configuration management system is complex. It has a database and a search engine and an API, and all that stuff is not trivial to build. It's a web application, just like you have web applications, or many of you have web applications, and so you know that running a web application has got a lot of moving parts. So the Chef Server is no different. So 2 commands, bang, that was easy. And for the question, who wanted me to talk about Chef versus Puppet, I'll be at the GitHub drink up tonight. That's it, thank you.